Because of its importance, the AIR data system has three channels. The left primary channel consists of the left pitot-static probe, the AIR Data Unit 1 computer, and the left index control panel for inputting barometric corrections. The right primary system uses the right pitot-static probe, ADU number 2, and ICP number 2. Both primary systems use the same temperature probe, located below the left wing root. It senses indicated outside air temperature, from which the AIR data computers calculate static air temperature and true air temperature. The third channel is the standby system, with its standby pitot-static probe located on the right forward fuselage. It outputs to the standby instruments. The pitot-static probes supply pitot pressure and static pressure to the AIR data computers. The static lines are actually connected and the data averaged before being sent to the ADUs. If there is a blockage in one side, it can be isolated by pressing the Isolate switch light on the panel below the left pilot instruments. Touch the Isolate switch light to isolate the left side. The Isolate segment on the panel illuminates. The primary probes are electrically heated by AC power and the standby probe by DC power. If you need to find the AIR data units, they're on the aft bulkhead underneath the circuit breaker panels. Output from the AIR data units via the ARINC data bus is used by many aircraft systems. For example, on the PFDs are the indicated airspeed, including the VMOQ, and some FMA enunciations. There is, of course, altitude. On the MFD is the true airspeed. On the engine display, the static air temperature. The AIR data computers also output to the power plant via the FADEX, to the cabin pressure control system, and to parts of the crew alerting system, including the overspeed warning and altitude alert. They also output to the AHRUs, to the FMS, to the ATC transponders, and other systems. In fact, to almost everything. Remember that on the index control panels you can set speed bugs. You can also set barometric pressure and decision height. These knobs are rate-aided. Remember that the AIR data side is selected on the ESID panel. If you see red failure flags, you need to move out of the norm position and you get the ADC source annunciator flags. Now the altitude alert system. When you pre-select an altitude using the altitude select knob on the glare shield flight guidance control panel, it's displayed in cyan at the top of the altitude indicator. Press altitude select to arm the altitude. Altitude select becomes the armed vertical flight guidance mode. When climbing or descending to within 1,000 feet of the pre-selected altitude, the alert goes reverse video yellow and you get the altitude alert chime. Within 250 feet of the pre-selected altitude, the yellow returns to white, and as you capture the altitude, the lateral mode becomes reverse video alt capture, normal alt capture, reverse video alt hold, and then just alt hold. Let's look at the system diagrammatically. Descending to a level off altitude, the yellow altitude alert comes on and the chime sounds 1,000 feet above the selected altitude. At 250 feet above, the alert goes off. If you deviate by more than 250 feet, the alert comes on again, together with the chime. And if you deviate by more than 1,000 feet, it stays on until reset by selecting another altitude on the flight guidance controller. But if you return to the selected altitude, the alert goes off. The overspeed warning sounds when one air data computer reports that airspeed is above VMO plus 3 knots. Reduce speed to silence the warning. Holding the left side panel's ADC test switch in the test 1 or 2 position tests whether each air data computer is interfacing correctly to other systems by displaying preset values. For example, a baro-corrected altitude of 14,360 feet and a VMO set to 284 knots. You'll also see these indications. Holding the switch for more than 5 seconds also sounds the overspeed warning triggered by each air data computer. Finally, the standby pitot-static probe controls data supplied to the standby instruments. It is completely independent of the 2 primary systems and can be used to resolve any air data mismatch messages.